CS 3351 Digital Principles and Computer Organization. Topic Synchronous Sequential Circuit, presented by Devi Visalaksha, Assistant Professor of CAC Department, Rohini College of Engineering and Technology. Classification of synchronous sequential circuit. In synchronous or clocked sequential circuits, clocked flip-flops are used as memory elements which change their individual states in synchronism with the periodic clock signal. Therefore, the change in states of flip-flop and change in state of the entire circuits accurate the transition of the clock signal. The synchronous clock sequential networks are presented by two models. First one is a Moore model, Milley model. Moore model, the output depends only on the present state of the flip-flop. Milley model, the output depends on both present state of the flip-flop and the inputs. Moore model. In the Moore model, the outputs are the function of the present state of the flip-flops only. The output depends only on present state of flip-flops. It appears only after the clock pulse is applied. That is, it varies the synchronism with the clock input. Milley model. In the Milley model, the output are functions of both the present state and flip-flops and inputs. This is a diagram for Milley model. Difference between Moore and Milley model. Moore model, its output is a function of present state only. In Milley model, its output is a function of present state as well as the present input. And input change does not affect the output. In Milley, input changes may affect the output of the circuit. In Moore model, it requires more number of states for implementing same function. In Milley model, it requires less number of states for implementing same function. Analysis of synchronous sequential circuit. Analysis procedure. The synchronous sequential circuit analysis summarizes as given below. Assign a state variable to each flip-flop in the synchronous sequential circuit. Write the excitation input functions for each flip-flop and also write the Moore and Milley output equation. Substitute the excitation input function into the BS table equations for the flip-flops to obtain the next state output equations. Obtain the state table and reduced form of the state table. Draw the state diagram by using the second form of the state table. Analysis of Milley model. A sequential circuit has two JK flip-flops A and B, one input and one output. The flip-flop input functions are JA equal to B plus X, JB is equal to A dash plus X dash, KA equal to 1, KB equal to 1, and the circuit output functions Y is equal to X A dash B. This is the logic diagram.